Hello guys, welcome to Data Explorers. This is the lecture 2 of our machine learning series. Or today we are going to see the types of ML. So I learned all different kind of things earlier. So this is types of ML. So here we are going to see different types of machine learning models we create. So first, there are basically four types: supervised, unsupervised, semi-supervised, and reinforcements. Supervised basically means those where we provide columns, both input and also output columns. We know the output and we give our models that these are the possible outputs. But in unsupervised models, what we provide, we only provide input data. We do not provide any output data. We don't define that, okay, this is the possible output. The model itself predicts the output. It itself identifies, okay, what are the possible outputs, all based on what are the algorithms we are providing, trying using for that model. And apart from that, this is semi supervised. Semi supervised is something when we have the output, but we don't have output for all of the input data. So it is somewhat between supervised and unsupervised, but it is really helpful. Because naming the data is really a costly thing because it requires human efforts. So semi-supervised is a savior here. By using semi-supervised, we can basically name some of the output columns and turn our data into supervised one with the help of semi-supervised. And reinforcement learning, it is somewhat that is totally different from supervised and unsupervised. Reinforcement learning is something like as human learns because they try something new. Either that new thing, the new experiment is a success or it's a failure. The model going to do it again and again, but if it is a failure or it is restricted thing, the model will restrict itself to not repeat that step in the further cases. So reinforcement learning is somewhat like humans learn. Like, you remember there is a movie that's named PK of Amir Khan. So like he used to learn, like there is an incident that he recognized that, okay, the any picture having the photo of Gandhi can give him, help him to buy food. So he collects all of the photos, posters, notebooks, and also currency notes also. So he took them to the shopkeeper and asked him for food. But the shopkeeper only provides food when he give him the currency note. So then he realized, that, okay, the picture of Gandhi at different papers has no meaning. It's only have meaning when they provide the picture of in that currency note. That particular thing is only important. So this is something like reinforcement learning. So later on, we divided all the other models into different algorithms. Like supervised can be classified into regression models and classification models. In the same way, unsupervised into classic clustering, dimensionality reduction, anomaly detection, and association. And also on further classification, you can see anomaly detection can also be used, further classified into supervised and unsupervised. So basically later on I tried to write all the different possible algorithms in each of these data models. Like for regression, we have linear regression, ridge regression, natural neural networks, lasso, decision tree, KNN, SVM, Gaussian regression, polynomial regression. In the same way, for classification, we have logistic regression, we have decision tree, random forest, SVM, KNN, naive Bayes. So these are just we. I tried to name this. You can have a screenshot definitely for all these algorithm, because it is not something like you will be asked somewhere for this, but it's for extra knowledge that, okay, in clustering we have this K means DB scan, Gaussian mixture, Birch, affinity propagation, mean shift, optics, agglomerate hierarchy clustering, decisive hierarchical clustering, mini batch K means. and spectral clustering. Apart from that, for dimension detection, we have PCA, LDA, and feature selection and feature extraction. These are also helpful in dimensional detection. So I have written them here. Apart from that, NMF, GDA, missing value radius, all these are different, some advanced topics, but I think I wrote them because I thought that okay, at least we should have something extra that will provide us extra edge from someone else who does not have not knowledge. Because as I have seen, usually in the starting phase, people not does not know about these extra concepts. So that will be really helpful for us. And after that, we tried to find the types of data we have. So data is of two types, numerical and categorical. Numerical data is further classified into discrete and continuous, while categorical into nominal and ordinal. So discrete is something that is of numerical values, but that is not of, that is of intervals. Like there are intervals, there are gap between first and second values. Continuous is, that is something continuous, and the best part about continuous is if you try to further open up, it's like something, if you try to zoom in the continuous value, you can definitely go there, that is possible. Like if you take the data of set of height, so in the height can be in a given range, it can be anything. Means if you try to make in millimeter, you can also get that height in millimeter, and if you try to get that in centimeter, you can definitely get it in centimeter. And if you try to make it smaller and smaller in that smaller unit, you will also definitely going to get the height. In the same way, age is also continuous, because definitely we can also calculate the age in the same way. Like someone's weight is also continuous, but discrete. Like if we are creating a gap of 10 numbers, like 10, 20, 30, 40, so it is discrete. Why it is discrete? Because we cannot zoom in, zoom out the things. Means you can't say that something like 9.5 in that particular section. So that is the concept of discrete numbers. And in the same way, in nominal and ordinal, nominal categories are normal categories. Like we have two to three categories, like yes, no, husband, wife, gender is male, female, this kind of thing are definitely categorical thing. But sometimes what happens that in the category there is some order, so that is ordinal. Like ranks, rank something like grade A, B, C, first, second, third. So these are ordered ranks. So there is first depicts something, second depicts something, and first, second, third all are not equal categories in itself. First means that is something like if in a class someone in is first, that means he is having marks highest. But if there are some colors in the categories like red, yellow, white, so here that does not means anything. So all the colors have equal values, so definitely that is nominal category. I think that this is helpful. Apart from this, I also learned about EDA. uh, so EDA is basically exploratory data analysis. So the basics, like we are covering the basics of everything. So I thought, okay, let's cover EDA basics also. So before learning anything in EDA, we need to understand that why do we need EDA. And for EDA understanding, what I took that okay, EDA is something that help us to understand the data. First, you will understand the data. Later on, you can only you can apply any machine learning algorithm in that data. So EDA help us to understand the distribution of the data. What are the outliers? What are the features of data in terms of mean, median, mode, and also help us to understand okay, what is the type of data? It is continuous, categorical, and it also help us to generate hypothesis. It help us to understand okay, what are the relation between the features provided, what is between our input column and output column. And also it helps us to find the balance between the data, that if data is really balanced or imbalanced. And apart from that, data validity. But data validity is tested when someone is having no domain knowledge. Apart from that, Model's validity is only checked by statistical hypothesis theory. And apart from that, if is our model going to make any sense or not, this is tested by model interpretability techniques. Like model, we are trying to okay test the output of the data. And here comes what I was telling you, the flow. Like what will, how the EDA will be applied, or when will be ML will be applied. Because as we are going to know, explore more and more about machine learning, we should know that okay, like we get the data, at which stage we can apply the ML model for getting optimized result. So the steps are something like, first we load the data, then we will apply EDA, and after EDA we can clean the data, we can wrangle the data, and after that we can feature the important feature which are really going to help us for our problem statement. We are going to only select those features. After that will do feature engineering, scaling and transformation to those feature. And after that we are going to apply the ML algorithm in it. We are going to use cross validation methods. We are going to later on tune the parameters for the best algorithm, because usually it is seen that after tuning, the algorithm always optimizes a bit, its performance optimizes or it performs better. After that we retrain our model for tuning our algorithm, and later on we deploy the model to predict for new data which is never seen, or we deploy after that. What I learned about something called time complexity. So time complexity is something that is really focused on software development thing, but in ML also we are going to code a lot and lot of things. Like if you, when you will move forward while deploying the model, our model is definitely going to deploy it in some website, some software, some application. So there it must be written in the some way that it will help us to optimize the efficiency. So having some understanding of time and space complexity is really helpful. So for understanding the time complexity, first of all, in this lecture we are just focusing on time complexity, because space complexity is something, the more and more space our algorithm is going to take while performing. So we will going to definitely cover it in the later upcoming sessions. And also it is, time complexity is something which is usually matter or given priority. Space complexity, if your algorithm is not that space specific optimized but time specific a lot, so definitely going, the higher priority is given to that algorithm. Because we, as we also learned yesterday, that with the enhancement in technology, definitely our storage capacity have increased, so there is no such space related issues that much usually occurs. I am not saying it is not important, but it is something that is given second priority. Time complexity have the first priority anyways. So time complexity, we have three methods. So what is, we directly calculate the time by calculating the timer, but or clock. But what will it result in? It will become machine dependent. And we can see, apart from that, we have second is, we can count the number of operations we can provide. It will definitely going to machine independent. But in that case, as we change our approach, it will going to change the time. So apart from that, we have order of growth. So in this case we just calculate the order. So that is third one. So on comparison first, second and third, what are the different possibilities with first, second and third, you can see. So here for understanding the order of n growth, so those who are just not here to revise, so here is example like how the order of n growth work. So if our algorithm is something of this structure, n square plus 2n plus 2, so order of n says remove additive and multiplicative constants. Like 2n plus 2, these are constants. In 2n, 2 is the multiplicative constant of n. So we will remove 2, it will result in n square plus n. And since n square is of greater value in higher term, when we have a large number of value of n, so n square is something that will cover n. So n square is the order here. In the same way, n square plus 1000 n plus 3 to the power 100, n square is the order. In this algorithm, log n plus n plus 4. So add since n is having more value than log n, so definitely n will be the answer. And apart from that, it's 0.001 into n into log n plus 300n. So here n log n will be the answer, because here 300 and n will be the output. Like I said, the multiplicative constant will be ignored, so here n log n is bigger than n. And apart from that, 2n to the power 30 plus 3 to the power n. So one is polynomial and another one is exponential. So in higher values of n, exponential will definitely going to beat polynomial. So 3n will be the output, or yes. So what are here comes I in our mind, what are the different possible of order of growth? So like we explored earlier, for the first one and the most loved, most desired one, and which usually not occurs that much, is constant value. Like if your algorithm is something, it is having constant value, constant output, then definitely it is the best one. Apart from that, we have linear algorithm which grows linearly. We have quadratic which grows quadratically. Apart from that, we have logarithmic order of algorithms. This is how n log n looks like, and this is how exponential look like. The polynomial will also somewhat look like exponential, but its graph will be a bit less steeper, but it will be something like exponential only. And this is quadratic one is the best one, representative of polynomial. Sorry, I so see the exponential and quadratic one, these are all similar, but the steepness is something that making the difference. So this is law of addition of in order of growth, like order n plus order n. If there is something like this, so we can make it 2 order of n, and like we see, we remove the constant values, so 2 will be removed and order n will be that will remain. Apart from that, law of multiplication is something like order n into order n, which can be multiplied into order of n square. So it is going to remain here, because now it became quadratic one. So that's it, guys. Here the comes the end of the revision lecture. I learned we discussed about the types of data, we discussed about time complexity, we also discussed about EDA and its importance. So in initial phase, we are just going to touch, we just going to scratch the basics of all. Later on, as we move further, we are going to use how these all different chunks. Like today you have seen that okay, time complexity is something related to software development, and also types of data is related to machine learning, and EDA is something that is related to statistics. But later on, what will happen when we are going to do data science, we are going to do practical project, will see that all these different spaces will merge into one and help really going to help us in future upcoming lectures. So that's it. Thanks, and we will meet in next time.